Hi there. I was just listening to Mozart, not because I'm much of a fan of Mozart myself, but because, I was listening to pure classical adult work with random composers, and Mozart was one of them. It's basically because I do think that listening to classic music while doing not just linear algebra, but, math in general is one of the best things that are, available for free in life. Anyway, today is a good day, and I'm going to talk about the bisection method. So, first thing first, the bisection method, you gotta know that is always gonna converge. But in order for it to converge, you basically need two things, so two main things. The very first one is that the function you are analyzing has to be continuous. And the second one is that you need two starting points, let's say y and 2, and those 2 points has to be one positive and one negative. So by having them one positive and one negative, you're basically going to find, the point in which this function is going to, go to 0. So basically, just, pretty straightforward. If you suppose that you have a function, like any kind of function, and it's continuous, and you have two starting points, let's say this one and this other one, okay, you basically, and this is continuous, so there are no discontinuity points. So it's pretty obvious that it's gonna pass from here, somehow, somewhere. And this is basically what we're gonna do. So let's suppose we have, I don't know, this function. I'll just make it a concrete example. So we have this function here, x to the third minus 9x plus 1 equal to 0. So this is the function we are trying to analyze. And we're going to need two starting points. Let's say x1 equal to, I don't know, 2.5 and x2 equal to 3. All right, so the very first thing that we're going to do is to analyze those 2 points. So we basically expect one of them to be positive and one of them to be negative. So let's see. We basically have the function in the point 2.5. This is basically going to be 2.5. We're just plugging this value into our function. So it's going to be 2.5 cubed minus 9, the coefficient times 2.5 plus 1, which is basically going to give us, 15.625 minus, 22.5 plus 1, which is going to give us negative 5.875. Okay, so this is basically our first value, and let's try see what happens in 3. So if I plug in 3, I'm going to have 3 cube minus 9 times 3 plus 1. And this is going to be equal to, 27 minus 27. So just two cancel each other, plus 1. So this is actually going to be equal to 1. So there you go. We basically have a negative value and a positive value. So we know that since the function is continuous, there must be a point between 2.5 and 3 in which the function, is basically, 0. It just crosses the axis. So let's basically draw a little, sketch for our graph. This method is extremely useful because you don't have to do all the things to analyze this function like the way you do in calculus. So it's actually used for complex functions and stuff like that. This like a very simple function, so we could actually have analyzed it like in a very simple way like we do in calculus. But the whole point is to show the bisection method here. So this is basically going to be our 0. This is the point, our starting point, so 2.5, and this is the other point, 3, that we have analyzed. So the value at 3 is actually going to be 1. So we basically right here, and the value at 2.5 is going to be negative 5.875. So we're going to draw it at the very bottom. So negative 5.875. So it's pretty straightforward because those are our 2 points, and it's pretty obvious that it's gonna pass and it's gonna cross the axis and go to 0 and then go till here, but it's not gonna be a straight line, like not necessarily. So we gotta find out where it's gonna cross the axis. And we're not actually gonna find, a very precise result, but rather an approximation. So we're gonna make our best guess. So in order to start with the iteration, we're basically gonna do a very simple thing here. So what we're basically gonna do is to find our XR, which is gonna be our guess for the dew point. So we're basically going to say, hey, we know that is negative at 2.5 and is positive at 3. So we're going to be, we're going to try to find a value and find a value here, like at a very, in the middle between this one and this one, and analyze it here and say whether it's going to be positive or it's going to be negative. So XR1, our XR1 is going to be 2.5 plus 2 divided by 2, which is going to give 5.5 divided by 2, which is 2.75. So our next value, so between here and here, let's say here, it's going to be 2.75. There we go. And now we're going to plug 2.75 into our function and see the output. So which number is going to give us. So f of 2.75 is basically going to be, if you remember the function we have, it's basically going to be 2.75 cube minus 9 times 2.75 plus 1, which is basically going to give us well, 2.75 cube is 20.796 minus 24.75 plus 1, well, negative 2.95. So, negative 2.95 is not negative 5, so we're getting closer, but it's still negative. So let's say, I don't know, let's say that is 2.95. So 2.75, 2.95, there we go. So, the function is going to go here. So, we're getting closer, but we're still guessing that it's going to pass between here and here. So, we basically found our value, which is here. If it was going to be, any other things like, I don't know, still positive, then our next guess would have been different. But since it's still negative, our next guess is going to be basically here, so between 2.75 and 3. So we're basically going to write XR2, which is our second guess. So 2.75 plus 3, which is on the other hand, divided by 2, of course. So 5.75 over 2 is going to give us 2.87. So our next guess between 2.75 and 3 is going to be 2.87. So let's see, let's just plug in 2.87. So f of 2.87 is 2.87 cube. We have our function here, So 2.87 cube minus 9.2.87 plus 1, which is going to give us 23.74 minus 25.83 plus 1 is going to give us negative 1.19. So, well, let's just say that it's roughly here, negative 1.19. So, well, let's say that it's here. So our best guess for this function is basically gonna be the curve I'm drawing here. So we expect this function to pass through here and to go here. So this is our best guess. Of course, we can go on and find a value between 2.87 and 3 and so on. So until we have found, you know, a very good approximation for this function and, you know, where it's going to pass through the axis. So the point is going to be more and more precise. So you can basically see why this method, this bisection method, is going to converge to our desired solution. But of course, this utterly uses the fact that the function has to be continuous, and the 2 points we're starting with have to be one positive, one negative. So why this? Well, because if the function is not continuous, there is no way that we can guess and expect that the function is going to go, you know, from one end to the other end, because if it's discontinuous, could be, you know, here and then the very next moment, you know, here or somewhere, like over there or over here, like pretty much everywhere. You know, there is nothing that tell us that is definitely gonna pass through the axis. So the function has to be continuous. But if if it is continuous, then we can use the bisection method. So, you know, it's pretty straightforward. It's pretty much it. I'm gonna make another video with another example, a few more, to be fair. All right, cheers.